Without further ado, I'd like to introduce the TriggerXR team. We have Kristen, Nathan, and James joining us, and I will go ahead and let them introduce themselves to you all.
Hey everyone, I'll make sure in the chat that you've got the direct links to the game too, so I can help the Niantic team there. But Kristen Glushon here, I'm the VP of Marketing and Partnership. I'll hand it off to Nathan.
Yeah, Nathan, I'm a software engineer here at Trigger, and I was one of the main devs on this project.
Sweet, and I'm James Roosevelt. I'm Director of Technology at Trigger. I've been working in the XR space for about 6 years and broadly in the gaming and mobile application space for about 12 years now. Feel especially attached to this project. If you could guess by the name, Teddy Roosevelt is my great uncle, so I wanted to be sure that his likeness and his passions were super well represented in this experience.
All right, well, I get the easy part of the presentation, but I also want to echo, as a mom of small kids, this is by far one of the most fun experiences that we built because it's really using technology to get kids outside, learning about nature and conservation. I'm going to share just a little bit about TriggerXR to give you some context, and I think one of the best ways to do that is to give you a sample of our work. So I will stop talking for a moment now, and I'll have our Niantic team hit the play button on our sizzle.
Pause here. I'm just going to make sure that the audio is on in the video, and then I'm going to go back to the QR code just because it seems like we wanted some folks to make sure that they get that. 1 second, y'all. Pardon the interruption. Here we go. So we're just going to go right back to the QR code. So we had a lot of people joining in. So if you'd like to experience the Rangers Wanted app, here is the QR code to download as we get ready for the presentation. Cool, I'll leave that on the screen for a couple seconds. Let's see. Cool, awesome. All right, looks like everyone's got it. Thumbs up, got it, cool. Thank you, Wayne. Awesome, all right, so let's move on to this video.
All good. Awesome. Well, thank you everyone again, and thank you to the Niantic team for having us here. As you saw from the sizzle, we work across all XR platforms. We help clients from the concepting through the development and the deployment of their campaigns, and working with some of the biggest brands and IPs in the world. We've had a long time relationship with Niantic Lightship. We were actually one of the first developers in their early developer beta, and have since, in addition to Rangers Wanted, rolled out, and you saw some of those featured there, as well as my face as a racquetball. We do use our employees for talent. But in addition to the experience that we'll show a video for as well, we've also built on Lightship the Coachella app experience, a PGA Junior League experience, as well as one for Universal Studios for their most recent release for Jurassic World Dominion. So we have lots of experience in the XR space. Look forward to really honing in on this experience. But if you have any questions about Trigger and who we are and what we do, just know that we've got a lot of years of experience across the entire spectrum of XR and across all different types of industries. So looking forward to sharing more about this game in particular. So I'll hand the baton off to James.
Sweet. Thanks, Kristen. Next slide, please. All right, so we're here today to talk about Rangers Wanted. So I'll start by giving an overview and some background info of the app. We'll talk about some of our game design approaches that we've gone through. I'm going to kick it over to Nathan after that, and then we'll wrap this up with some overall project learnings. But first off, this was a massive collaborative effort between us at Trigger, the TRPL, who's the Teddy Roosevelt Presidential Library Foundation, Niantic, of course, whose technology is powering this whole experience, and the Future of Storytelling, who's helping us with like the narrative direction here. Overall, our goal was to engage like a younger generation, teach them more about their environment, conservation, and really push that kind of educational aspect of this while keeping it fun. The library itself is under construction. They broke ground, I think, last year, and it's set to open in North Dakota in 2026. We wanted to promote that by creating this experience and championing Teddy Roosevelt. And again, targeting younger audiences was our main focus here, but we wanted this to be fun for kids of all ages, for anybody, with the overall goals to get people outside, give them some knowledge about the animals in this experience and how important they are to their ecosystems. And then lastly, kind of like our final goal here, well, final couple goals, we wanted to leverage some of the great features that we were already kind of familiar with from ARDK. So for us, that was kind of meshing as well as the game board features we'll talk a whole bunch more about later. And our last goal here was to really ensure that this was a safe and good experience for kids. So we partnered with KidSafe to go through their certification process and obtain that certification. Okay, next slide, please. So I'll give you an overview on the exact experience. I think we have a small video to follow this one. But Rangers Wanted is an AR app where Teddy Roosevelt's taking you on super fun conservation adventures. He's auditioning and looking for rangers to join him. And he tasks you with solving problems for animals. And these are very crucial, important animals to their ecosystems, and kind of give you learnings along the way. So the game uses Lightship to convert your room into the environments of these animals. So you could be playing in a field of wildflowers, you could be playing in the Arctic tundra, or like a jungle setting, depending on the animals. Users will advance through levels, play a bunch of AR mini games along the way that corresponds to each animal, learn about these creatures, and collect badges and collectibles along the way, which is kind of like our educational component of this experience. The exact animals you're going to be working with and partnering with are the beaver, where you'll help him patch his dam. You'll work with the ocelot, the Arctic fox, the bumblebee to help pollinate flowers, or like the woodpeckers you can see here to look for worms in trees. Okay, next slide. And the results. Overall, I'd say this was a really good success for us, for Trigger. We were able to get the KidSafe certification, which of course makes parents feel better across the board, knowing that there's not dangerous link outs or things like that in the application. We made use of several wonderful AR features and kind of found that perfect hybrid synergy between some of the learnings we wanted to do, fun gameplay, as well as the tech to drive it. We implemented a badge collection system, which is where, again, we're driving a lot of our educational components of this experience. And at the end of the day, we're tying this all back to Teddy Roosevelt, the Presidential Library, and a lot of those ideals that they wanted to convey to kids of all ages about conservationism. And lastly, we were able to, kind of with the timing of the app, leverage some really good marketing media promotional opportunities through family sites and social media that helps kind of push this out to a broader range of users. Okay, next slide. This should be the small sizzle for Teddy, so enjoy. that song will forever be burned into my memory, and for good reason. It's catchy as heck. Next slide, please. Cool. So let's start off by talking game design. I'm by no means an expert game designer, nor was I necessarily playing the role of game designer in this project, but I think our approaches here and our considerations across the board in terms of game design helped us in delivering this project. We'll start off with the challenge here. We all know as developers, games are hard. Building these kinds of experiences are super hard for a ton of reasons. Whether that's time constraints, budget, resourcing limitations, iteration or polish that you wish you could be doing, or just purely nailing the fun factor of something. So the ultimate question for us became, how do we approach the game design in a way that ensures successful delivery, making sure things are fun, unique, and interesting across the board? And the next few slides are going to be our solutions, or what we think were our solutions to address that challenge. My broad message here in terms of game design is game design should be used as a tool to combat these difficulties during the development lifecycle of a project. Next slide. Thanks. Cool. So the first one is we approach this from a gameplay perspective. We wanted to establish like a repeatable gameplay loop that wasn't super different from start to finish, but with a little bit of variance somewhere in this process. And that's going to come in this diagram here during the puzzle section. So for this puzzle section, we could swap that piece out with multiple types of gameplay. So in some cases, you'd be matching and doing an actual puzzle challenge. In other cases, for the mini games, you will be doing like a spam tap as quick as you possibly can to race and beat the clock kind of experience. So there's variance in the gameplay types. There's some variance in the timing between those things, and we'll cover more of that in a slide soon to come. And overall, that kind of what we think that increases replayability, keeps the gameplay fresh as long as there is variance in between those mini games, which will hopefully bring users back into them to revisit them and hopefully not grow too tired of them. They're less repetitive. Next slide. The next one was the mechanic. So we wanted to distill this down to the simple, most repeatable, common mechanic possible across all those different types of mini games and like gameplay styles that we wanted to feature in this experience. In our case, this is a tap or touch events. This is good because it kept it familiar. We didn't need to explain this a ton to a user up front. We'd say tap the thing with very minimal instructions. It reduces iteration because there's no other kind of interactions or fancy gestures or things like that you need to support, which is hopefully very easy for kids to figure out, is draw their attention to something and tap the heck out of it. And I was kind of like thinking about this a little bit, and at the end of the day, like this is very similar and comparable to a classic mouse click input. And if you think about all the games that have been developed since the history of gaming, like the mouse input click is about as versatile as it gets, and I'd like to think as like the touch component or touch events as the exact same thing here. Okay, next slide. I talked about timing earlier, and that was another component or approach to game design that we leveraged to make our games feel unique and different from one another. Not only does this help with like the just length of the game, but it also plays into things like scoring and our star system, which is what you're seeing kind of like at the top of that little GIF there. A lot of our games like this one here were intentionally slower, where you're just looking at things and matching patterns. Others were a lot quicker, maybe half the time, 30-second gameplay or shorter, where you're just tapping stuff as fast as possible to rack up as high a score as possible in much less time. So I think that, you know, having these varying length of mini games really contributed to them feeling more unique across the board. Next slide. Lastly, this one should be obvious for all of us. It's AR. So take advantage of what AR lets you do. And that's the space that the users are playing in. We wanted to support a variety of spaces from indoor to outdoor. So the questions that immediately came up as soon as we made that choice is, one, okay, how do we scale our content if we're playing indoors in a small room that's maybe 3 meters by 3 meters? How do we scale that, make it fun still and still achievable and not more difficult when you go outside? And we want to add more content in a larger play area, maybe 5 by 5 meters. So those are the kinds of considerations where we were thinking of right off the bat, scaling content. But beyond that, the other really cool thing is given AR and 6-stop movement, you can actually think of that as its own gameplay mechanic. Movement can be a mechanic that can encourage a type of gameplay or heighten a sense of like urgency in the gameplay too, which is something we found pretty early on and we really leaned into with like those outdoor situations and forcing users to move around the play space. And lastly, when you are using physical world as your play environment, we found adding some immersion to that, adding decorative elements beyond just the purely interactive gameplay elements, really made the user feel more in that virtual play space, or really just blend the two together. Next slide. Cool. And lastly, we wanted to think about how education played a part in our game design. We wanted there to be really cool educational moments that weren't forced into the gameplay at the cost of potential gameplay. What we came up with was our badge system. So at the start of the gameplay loop, before you jump into a minigame, we'll look at the beaver, for example, here. You're approached by Mr. Beaver, tells you what you're going to be doing, how you're going to be helping him. During the gameplay, you're just doing his task. You're fixing his dam. There's some other little nice to have collectible features in gameplay, like a firefly moving through the scene. That's by no means required to interact with in order to complete the game. But if you do, post-game and beyond, you'll unlock additional tidbits of information. And then when the gameplay loop is over, exactly, it's an Easter egg. You nailed it. When the gameplay is over, we offer a couple options for users. You get your tier 1 badge for immediately completing the game at any star rating, whether you're 1-star, 2-star, 3-star, which gives you a little bit of information there, which is that middle badge you can see there on the bottom. Just a little bit of information about the beaver, his ecosystem. And then we offer a tier 3 badge as well at the end of it all to hopefully bring users back into that game, achieve that 3-star rating, and collect more information. So we hope that kids are driven by this to make gameplay fun and reward them with badges, as well as tidbits of information along the way without kind of coming at the cost of gameplay. And largely, I think it worked out well. Okay, I'm going to hand it over to Nathan now to talk about some of our technical approaches. Go ahead, Nathan.
Yeah, thanks, James. Next slide, please. So the main part that we used AirDK for with this app was the whole placement flow of everything. So that all starts with meshing, of course. And I'm sure many of us here are familiar with it, but we're basically just reconstructing the physical world that we're scanning with your phone in a virtual space. So this process isn't instantaneous. So the user has to actually walk around, move their phone, and scan the area to fill out the mesh that they're trying to build. And the meshing data also becomes more accurate as the user is scanning. So something we'll talk about later is dealing with like very early on inaccuracies in the mesh data and how we work around that. And then from a more technical perspective, with this app, we kept our meshing parameters fairly low detail. So it's not a super high poly mesh just because we're potentially scanning a pretty large space. So as you might have seen in the video from earlier, the user chooses whether they want to play indoors or outdoors, and that setting will change a few different things in the app, but namely change how much space we need to scan, and then some of the detail parameters. Yeah, next slide, please. So part of the way that we, I guess, gamified the scanning process is we place these decorations in as the user is scanning, so it's a little bit more interactive and there's something going on besides just filling a meter. And throughout development, we referred to these elements just broadly as rewilding. So each animal essentially has a collection of prefabs that represent these different rewilding elements. They're typically some kind of like flora or maybe just other small natural decorations that are related to that particular animal. And the whole process that we use for placing these down, they get randomly selected from that collection and then placed in the user space. There's also some minor variations that get added to each one of them. So they'll be scaled slightly different, rotated a bit just to like make it look less uniform. And then finally, when we place the actual game content, whether that's a single object or lots of objects, what we'll do is trim out spaces around these elements. So that way we're not having weird overlaps where the flowers or whatever else are getting in the way of seeing the gameplay objects. Next slide, please. And then to talk about optimizations here a little bit, as you can imagine, we're creating lots of objects here during this whole process. So without keeping optimization in mind, it could get pretty expensive, especially for a mobile game. So initially, we tried to go about this as like the best way possible, where we're just drawing everything directly using graphics draw mesh instanced. So with that, it's basically like a pipeline straight to the GPU where we're instancing everything. And we ultimately didn't end up going that route for a couple different reasons. While we did get it working, a lot of the meshes or the different assets that we're using here for flowers or whatever else, they weren't created bespoke for this experience. So you'd have a lot of instances where certain flowers might have multiple submeshes, multiple materials or otherwise, and trying to like process those after the fact wasn't necessarily within the time frame that we could accomplish. But even beyond that, tracking the instancing data for lots of different objects or different prefabs all at once, and then also you can kind of see in the GIF here, these things aren't just popping in and out, they grow into your space. And then if they need to get removed, they grow out of the space or they shrink down. Trying to apply animation to instancing data would be pretty tricky, especially for this many objects. So what we ended up doing was settling for object pooling, which is still pretty performant, all things given. Basically, as soon as we load a game in, we create an object pool for each different prefab that we have in the decoration collection. And then after a certain point during scanning, if the user has too many objects placed in, we'll cap it at a certain amount and then start removing whatever the oldest instances are. And then additionally, as I mentioned earlier with the meshing data, we're placing all of these things on the mesh and we're placing them almost immediately as soon as the user starts scanning. So with the meshing data, those first couple seconds are not necessarily super accurate. You might have instances where the mesh, there might be chunks of it that are floating above the ground, maybe just not mapped to the floor super well. And we wanted to avoid instances where these objects would get placed inaccurately, like you'd have them floating from meshing data early on. So one of the things we did to try and mitigate that is we iterate one decoration instance per frame and update its placement after it's been spawned. And we cap that at one decoration per frame because it would, again, get super expensive if we started trying to update lots of these decorations every single frame. But yeah, one per frame worked pretty well for what we were trying to accomplish here. So that's what we went with. Next slide, please. And yep, so the next big piece on top of this was the game board. So the game board is basically just taking that meshing data and giving you an extra contextual layer on top of it where we reduce that space just down to what works well as a play area. So there's lots of different ways you could go about using this, whether you use it for navigation or placement like we did here. But essentially, we use game board as a tool to determine where we want to place stuff and determine if the user has scanned enough room to place stuff in to begin with. So there's a couple different things we use as criteria for that scanning process. The big one is the area of the current game board. So we want to know if the user scanned enough space in the first place. You can see at the bottom there, this is some earlier on UI from in the development process, but we have a scan meter that fills out that matches the meters squared area that's been scanned. And the specific amount that we require changes for indoor versus outdoor. So you can imagine if a kid's trying to play this game in their bedroom, there might not be a whole lot of space, and we don't want to, we want to make sure they can actually play the game. So we keep the scanning requirements pretty small for indoor, but then for outdoor, we bump it up quite a bit because we want to, if we can, encourage movement throughout this entire gameplay process. So after we've checked the area for the game board, the second thing we want to do is know, is there enough room to actually place the object down? So if you think you could scan one straight line, like imagine a hallway or something where you could fill that area requirement, but there's not actually space to place anything. So we, on top of the area check, we check that there's actually enough space around whatever position we want to place the object at on the game board. And then one final note here, we want to prioritize placing content in front of the user. So whenever we're doing our queries for the game board, we're usually checking either with a camera raycast or some other method where the location we're checking at is in front of the user and not behind them, because otherwise you're going to have an instance where the game starts up and the user doesn't actually see anything on their screen. Next slide, please. Okay, so to get into the details a little bit more with placement, there's two sort of categories of mini games that we have. There's a mini game that uses a single gameplay object, and then mini games that use multiple gameplay objects. So the beaver mini game, for instance, is a single gameplay object. There's just the beaver dam that gets spawned in the middle of your play area. And in this case, we're basically just doing a fitment check. And the logic for that whole flow is as follows. First, we want to find a position to place things at in front of the user. And what that step gets broken down to, we'll first try and use a camera raycast at the game board to look for that position. But there's a lot of instances where the user might not actually be pointing the camera right at where a game board tile is at. So if the raycast fails, instead we'll try as a backup. There's a find random position on game board. And what we'll do for that is take the user's position and add the cameras forward to it, and then flatten that to the ground plane. So that way you're not like pointing into the floor or up or anything. And we'll use that position that we get by adding the forward to search for that random position. And we'll just use a fairly small radius for that because we want to ideally get it very close to whatever position we calculated. And then ideally, that'll give us some position that's roughly in front of the user. So assuming that we get a position by either one of those methods, we'll then second check that the user's far away enough from the placement position. So we don't want the content to spawn, like we don't want the user to be standing on top of it, basically. And that distance will account for when we do those raycasts, when we do the find random position. So it'll be larger than whatever that minimum we need is. But we'll want to check that since find random position can introduce some approximation. And then third, we'll want to check that the content fits using the game board's check fit method. So essentially every piece of content we spawn in has a radius requirement that we include, and we just plug that into check fit and we get a true or false whether or not it fits in that space. Right, next slide, please. And then for placing many objects, the strategy is a little bit different. In the games where we have many objects, the objects are a lot smaller than like the beaver dam, for instance. So we still need to make sure that they fit, but the process is a bit more focused on finding a place for lots of objects to fit at, and then spacing them out in a way that fills out the play area in a way that's nice. So we want to place things randomly, but we want them to be placed uniformly. So you can see in the graphic, the right side would be a pure random distribution. So you can see that like the dots are clustered in different places. They might overlap. It's not guaranteed to actually fill out the entire game board that we've scanned in. And then also we run the risk of having game elements overlapping with one another. So to get around this, we use the Poisson disk sampling algorithm. And essentially this lets us put in a radius as a parameter for each object that we want to place. And the algorithm will give us a random set of points that are non-overlapping and are at least that object's radius away from each other in distance. But it'll tightly pack those output positions. So what's nice there is we get that random distribution, but it's still uniform in the sense that they're roughly equally spaced out, they're not overlapping, and they fit in the bounds that we provided. Right, next slide. And then one final note, we also intended to include occlusion in the app, but there were some interesting things that were particular to our app's design that prevented this from working well. So there's a few different ways you could go about doing occlusion. The probably best way, and the way that ARDK explicitly supports the best, is depth-based occlusion. So that's going to be using the camera's depth texture to determine what's in front of something, what's behind something. And there's lots of ways that you can change the accuracy on that, whether you're tracking a particular object in the scene or otherwise. But the issue that we ran into was we're placing a lot of small objects directly on the floor. So these issues would be particularly prevalent with the rewilding elements, where you have like the small flowers and everything that are right on the floor. Essentially what would happen is the depth texture would not be like accurate enough at certain distances to not start clipping certain elements in and out as you move around. So another way that we tried to work around this was by using mesh-based occlusion. You think we already have all this meshing data, we could just put a occluder material on it and use that to hide things. And of course, there's some immediate problems with that. Like we got to assume that the user has perfectly scanned anything that they'd want to have as an occluder, which is not going to be the case. But even still, we kind of ran into the same issue where the meshing on the floor is not going to be perfectly flat enough to not start occluding certain elements. And then the final thing that we tried was ARDK lets you sort of exclude certain areas from meshing by using semantic segmentation. So what we attempted to do was use the floor semantic to basically like cancel that area out of any occlusion that we're doing. But you can see in the GIF that we included here, the semantics are horizon based, or that's what their model is based on. So they work really well when you're pointing the camera out towards the horizon and you have like sky, trees, ground, whatever else. But it falls apart when you face it right down at the floor, which is really no big surprise. I mean, if you point your camera straight at the carpet, how is it supposed to know what it is? But you can see here that all of the like flickering is because the semantics are failing when you look at the floor. Yeah, next slide, please. And yeah, that wraps the tech discussion, so I'll pass it back to James.
Awesome. Thanks, Nathan. So we'll close this one out with some just overall project learnings along the way. Next slide, please. Cool. So this is overall project learnings. I think the biggest one is really just take advantage of AR and the play space that you're given. Beyond that, consider all different types of players that might be playing your game. Interesting enough, when we went through the play testing, portion, kind of after beta before launch, a lot of people were spending time in just the rewilding part, which is the decorative, like transforming your room or your play space into the animal's environment. So I think like knowing that now, I think the whole team would consider a different approach there, or maybe leveraging that rewilding portion to some greater extent. Again, think about how the space can impact the experience, encourage movement, because that's what makes AR fun. It's also a game mechanic in itself. And broadly, don't be afraid to throw away work. Actively make that choice to not move forward until you're ready, until something feels fun. But again, the big note here is like AR and movement are game mechanics in themselves that you should absolutely leverage. Next slide. Yeah, and some more further game design learnings is broadly, the message I've been trying to preach in terms of game design is a tool that can be used to combat other project constraints. So use it to your advantage. Games are hard. Take advantage of anything that makes your life a little bit easier. Identify those common reasonable mechanics that apply to all portions of your game, because they're going to help speed things along and lead to successful delivery. Educational aspects or components of games can also be introduced in ways that don't come at the cost of your gameplay. There's always creative ways to implement those, I think. And broadly, when you approach things in this way, with those reusable components or loops or whatever, these set you up to add more content to your experiences over time, which is always a good thing. We want to expand this, always want to solve through more work and expand your projects. Cool, next one. And tech learnings. Nathan, you provided a lot of these, but I'll run through them. My somewhat brutalistic approach here in terms of testing and like just testing on devices, nothing matters until it's running on the device and you're testing it on a device. You can test and debug in Unity or a simulator all day, but like until it's on your phone, running in your space or on an HMD, like you're never going to have the real sense of something. So I think that's imperative in the way that you approach these projects. But otherwise, defining our code architectures up front was really essential. How we wanted to approach mini games and kind of leads into that like shared aspect of mini games is what functionality can we identify that's shared across all of them and create architecture that matters for that. Keeping track of build size is always a big one throughout the project because the requirements are changing pretty regularly in terms of like the Play Store and the App Store on iOS. We learned Lightship makes a lot of really cool features available. Gameboard made our lives way easier, and it's still probably, from our perspective, one of the most underrated features of the Lightship ARDK. And again, prototype as early as you can. Don't get caught up in optimizations with small returns early in development. Just thinking about looking ahead, those things can always come later. And lastly, separating game data from prefabs using scriptable objects was kind of key to our success here. So definitely recommended for other games of this type. And I think that's the last slide from our presentation. So thanks to everyone for attending today. There's a lot of people in attendance that helped make this project. So shout out to everyone that lent a hand in producing this wonderful game that we built. Thank you.
Cool. Awesome. Thank you all so much for that presentation, Nathan, for the detailed overview of all the technology that you all use. I think that was super fascinating to understand. So really great job on that front. So we'll go ahead and start our Q&A session now. For those of you that have additional questions that aren't in the Q&A, please feel free to type them there, or you can raise your hands and we'll go in order as they come through. Yeah, see the praise coming through. I'll let you all enjoy that. Awesome. Okay, so we have a question from Piero. Piero, would you like to unmute yourself and ask it directly? If not, it's okay, I can ask for you. All right, cool. I'll go ahead and ask the question. So were there any thoughts? Oh, Mike is not going to. No worries. Were there any thoughts on using mixed reality a lot more in this project? For example, virtual birds landing on a real tree outside. When do you decide to mix elements of reality and virtual, and does it bloat and scope any major challenges worth noting on that front?
Sure. That's a good question. I could probably start off with this one, but Nathan or Kristen, if you want to chime in at any point, please feel free to do so. I think in our case, introducing that aspect of mixed reality would have kind of bloated our tech stack a little beyond comfort to some extent. We're already using some pretty heavy systems like meshing, game board, and stuff like that. And I think in order to make that work in the sense that you're describing with mixed reality, identifying actual trees, other things in your environment, we'd probably look to implement semantic segmentation running at all times across the board to identify those things. So that's probably how we try to make it work. But from our standpoint, the way we approached it is we didn't necessarily want to do that from the start, but introduce these pieces of virtual content and 3D from the animals' environments into your world to convert your world into their ecosystems. So that was our approach there, but it would be super cool to have the animals interact more with the world that you are in too.
And check out the Dino Tracker app if you want to see some of that as well.
Sure.
But I will also just echo what James said. You know, one thing that really informs a lot of our game design too is the strategy of the client. And so in this case, I think, although, you know, again, the experience can maybe evolve, the fundamentals that James explained are what really drove the UX. So just kind of always bringing it back to who the audience is.
Awesome. Great. Thank you all. All right, we have a next question from Breeze asking, how do you accommodate for changes in the real world environment after the initial mesh is complete? For example, if terrain, floor changes, or any new structure is added.
Good question. Nathan, do you want to start with this one?
Sure. So we really don't. Essentially, during the whole scanning process, that's when we're going to have meshing and game board and all that turned on. But after the fact, we typically want to turn that off just because they're both pretty expensive processes to keep running in the background. So yeah, we're really not accommodating for it. You could certainly start the game over and like go back through that scanning flow and update things again. But by default, yeah, we're just turning stuff off after we're done.
Gotcha. So is this essentially like new scans each time the user is opening the app?
Yes.
Got it. Okay.
Yep.
All right. There's a couple questions regarding usability of Lightship. I know Joe Gabriel, you're in the chat as well. I don't know if maybe we can push these to you for that front. I'm looking for questions specifically for TriggerXR. So for those of you that have tech questions, I think, yeah, I can read through some of them. And there's one about the devices that you can support. I don't know if maybe James and Nathan, if you all tested it, but the question is from Sandir. I understand the target audience might not all have the newest smartphones. What are the oldest Android and iOS devices you've managed to support?
Yeah. So this is mostly going to be driven by, I think, the Play Store requirements specifically for Android. And their requirements for submission are kind of updating once or twice a year, I'd say. I think their bare minimum requirements right now are Android 13, if I remember correctly. And I think they give you a full readout of broadly the device support that you can expect when you set your minimum Android versions to that level. So I'd like to say that we're compliant on the majority of Android 13 devices just by adhering to the Play Store's submission requirements.
Awesome. Cool. Thanks. And then we had a question from Rob that Joe Gabriel answered. Thank you for that. Marcelo has an additional question. With the technology, can I frame a QR code or image to precisely position a church on an outdoor street? Not sure if Joe, you have an answer for that.
Yeah, short answer here is that, and this, I think this will answer a couple other questions that are in here too, is that Lightship is a Unity-based SDK, and it is compatible with Unity's AR Foundation. So C# friendly, image tracking friendly, meshing friendly, low device support. This also means that you're also getting Android and iOS support across all of that. So excellent questions. Keep them coming, guys.
Awesome. And then James, this is a really interesting question. I know you all have experience working with Eighth Wall as well, but one of the questions is, would a AR game of this scale work as a web AR application too? So many people are reluctant to download apps.
Yeah, I mean, our whole idea is to allow these things to exist on as many platforms as possible, whether it's app or HMD or WebXR. And what we like to do too is think about how they synergize with one another when they're on all those platforms. So in terms of this experience living on like WebAR with Eighth Wall, I think we'd have to consider some of the tech components that we're using. Like I'm not sure that game board and some of those kinds of things are one-to-one necessarily on the Eighth Wall platform as it is on app. Maybe Joe could speak better to that than myself, but assuming they are, then yeah, there's a good likelihood that these things can exist on multiple platforms. Of course, on web, there's a few more limitations you have to consider in terms of app size, poly count, more so than you would on a mobile app. But you can always make those kinds of tweaks to support that platform.
Yeah, I
Cool.
love this question. I think
Yeah.
the dynamic between WebAR and like app-driven usage, these are really important considerations. So the big one I think that always comes to mind is like, how long do you want to keep this available for use? For shorter form, shorter period type of like, say, marketing activations or event-specific things, app download friction is a real deal breaker sometimes. So you need the ease of access that WebAR can provide. Whereas if you're looking for more of a live service ops or a like, I want this game to be alive for the next year or beyond, type of direction, then that's where kind of app-driven development will be your friend. And then there's just kind of the complexity of the experience itself that can drive a lot of these technology questions. If you're looking for multiple agents or multiple characters or kind of a broader expanse of kind of environment or characters in living simultaneously in your scene, then you're going to need a more robust kind of game engine to support that. Whereas if you need a more focused kind of bit of content where like I just need one thing to really do a really cool thing in my scene, then WebAR is a strong consideration for you too. So these are great questions.
Awesome. Great. Thank you. We have another question from Todd, and this is a feedback related question. What has been the response on the badge system with kids? Have you heard that they're printing them out?
Yeah, so we've implemented analytics to track this stuff, and we've seen people sharing these badges and whatnot. To the extent I'm not exactly sure number count, but we are seeing some engagement, beyond unlocking the badge, of users sharing those to social media. I don't think it's as strong as we wanted, of course, but we are seeing some sharing happening there. As to printing it out, I hope people are doing that. I don't know how they would track that, how we would be able to track them printing it and maybe posting it up in their room or something, but that'd be really cool.
Oh,
One
awesome.
comment too on just deployment. Wayne said something in the chat that I thought was great, which is he said a response to if you build it, they will come, and then the comment he said was sometimes, and I think that's a fair point too, because this experience we had a soft launch with the client timed to President's Day, but the expectation is that they want this because the library is not even available yet for us all to visit, that this will be, something that hopefully is more evergreen. They want to have QR codes on signage, once the library is there at their gift shop, et cetera. But thinking about how you release the app experience, or really any experience, is equally important sometimes as what you've built. So just know that, as we're tracking this, hopefully we are taking in that feedback and looking for ways to optimize the app as well.
Cool. Thank you all so much. Corbin has a question regarding to kind of like the challenging aspects that you all face. Broadly, what was the most challenging parts of developing this project? Were there any significant moments beyond mesh instancing, occlusion that you had to retool, reimagine to make the experience work as imagined?
Absolutely. And I love this question too. I think we'll probably popcorn around to each of us and we can each give something else. But for me, I think the game design was a big challenge we had to work through as a team. Not to reveal too much about the process, but like we had a lot of cooks in the kitchen on this one, a lot of people involved with a lot of different approaches. We had the narrative concept locked. We knew the story we wanted to tell for each animal and for Teddy along the way. But I think for a while we really struggled to identify how we implement the game design, what the mechanics are. So that was a really fun problem to solve for the entire team kind of early on. So that would be my answer.
Cool. And then a follow-up to that was, Could you speak a little bit to the marketing approach for the game and any challenges experienced there?
I can jump in there, although James has been featured in a lot of our marketing collateral as well. But as I mentioned, it was a soft launch, primarily affiliated with like a PR push, a public relations push by our partners at TRPL and Future Storytelling, along with the help of Niantic and TriggerXR. And like I said, hopefully as we market this going forward, there will be opportunities with actual physical locations for you to scan the QR code and download the app. But for right now, it's been really focused on PR and thought leadership and more of that grassroots marketing. And hopefully we'll expand to maybe some bigger media outlets and more on-site, out of home as well.
Awesome. Great. Thank you for that insight, Kristen. Pierre has a question that you kind of touched on already, James, but what was the scope of the project like Dino Trackers and Rangers Wanted? How many people are in a team, and what does the total time per project look like?
Sure, I can speak to a few of those things. They're a little bit different between these two projects. I think Dino Tracker was a little bit larger in scope, a lot more assets, a lot more I think client requirements, just because we were working with Universal and their standards for their 3D content that were showing the dinosaurs was super high, as they would be with like any movie studio. So I think that one was larger than Rangers Wanted, but our typical project setup is 1 to 2 engineers. Will have a creative on board to create UI comps for our developers to implement. Projects are led by project manager, all the oversight capacities across the board. And if I didn't mention already, also a 3D artist to support 3D content being implemented into the project. So fairly small-ish teams, but again, this could scale depending on the project. I know Dino Tracker had 2 engineers on it at one point, maybe even 3. So it's kind of as needed, but that's roughly the sizes we support at Trigger.
That's awesome. Okay, we have time for one more question, and then I want to make time.
Pablo, can I grab this last question for Trigger?
Yes, that's where I was going to. Yeah,
oh, amazing. Thank you. What y'all don't know is kind of the extra effort before this production even took off that Trigger undertook to kind of work with Teddy Roosevelt Presidential Library. For any developers and entrepreneurs kind of on this call that would love to work kind of in this category of applications, what are some tips to working with these types of larger organizations that might move a little more slowly, kind of more on the biz dev side of things?
Oh my, should I start us out there on the TriggerXR side? I think the key is just aligning on what those North Star KPIs are, and making sure that you're developing and strategizing against those key KPIs. And then I'll just go back onto my comment about what does the campaign deployment strategy look like as well. But overall, from a business development perspective, if you have a compelling concept and you think it's going to increase awareness or engagement, those are ultimately the types of marketing activation results that most brands are looking for, and the types of brands that we're working with here at TriggerXR. But I'll let James and Nathan and anyone else maybe share more on the technical side too.
Nathan, I'll let you share any thoughts if you have any.
Yeah, particularly for organizations that might move a little bit slower, or deadlines or goalposts that kind of move out over time, just anticipate that your requirements for build submission might change. So that's something we definitely ran into on this project is Google Play, their requirements change pretty frequently. And even just the duration of time it took from our original launch date to when it's now been moved to, they changed so significantly that we had to go back through and fix quite a few things just to get the submission through. And that wasn't bugs that were issues with the app or anything. It was certain libraries that were included in the AR build process and all that were just deprecated now, that we had to go through and go through all the Android manifest, all that, clear it all out. So it's kind of a pain, but just anticipate that.
Cool. All right, and that brings us right to the top of the hour. Thank you all so much for joining us for this amazing event. Thank you to TriggerXR, James, Nathan, and Kristen for an amazing talk. Keep an eye out for the post-event video and survey that we'll send out to everyone to catch the replay of the whole thing. Thank you all so much.
Thanks, everyone.